Okay, my name is Mohammed Sayed, and I'll be presenting Lookout and generally the notion of AI for cinematography. And this work is sort of from our paper, and these are the authors. They're all UCL academics. Okay, so before I go forward, I sort of want to sort of motivate the problem. So we're all familiar with scenes like this. This is from the movie 1917, and what I'm pointing out here is the camera. Right, it's a camera that's very close to the action. It moves around and with other actors, and this is called a tracking shot. And it's very dynamic and very fitting for something like this, an action film. But really, for the longest time, shots like this were not possible, and you were limited by wherever you can put tracks down for your camera. And tracks, by that I mean something that looks like this, where you place a dolly, what carries the camera here, onto these tracks, and then you get to move the camera along just these tracks. Now, as you can imagine, this is sometimes very inconvenient. You can't always put down these tracks, and it's very restrictive about where you can go. And the alternative is just freehand carry the camera, and that leads to a very shaky camera indeed. So thankfully, around the mid-70s, a man by the name of Garrett Brown invented the Steadicam, and here he is modeling it. And all it does is isolate the movement of of your body from the camera frame. So camera is no longer shaky now, but you get to run around with the camera and film what you want very smoothly. And in fact, many of the earlier films from the mid-70s will have his own handiwork here. This is himself filming these from very popular movies that you're probably familiar with. Okay, but there is still a problem. This gets you part of the way there, we argue, and there's still room left to improve. And or before that, sorry, this of course spawned new hardware. So there's again the Steadicam on the left there, and a sort of a more modern version. And there's also these motorized gimbals, which really are things that allow you to isolate rotational movement from the camera. So you can move the gimbal around, but it'll stay pointed in roughly the right direction. Okay, so yes, the problem. You still need to focus on what you're doing. So here, this is early test footage from Garrett Brown again, and he's trying to film his then girlfriend. It's very hard because he's going down the staircase, and he also has to point the camera. The camera's smooth, but you still have to point it. And you end up sort of being torn between doing one of two things. You either need to focus the camera and point it at the right thing, or you need to mind where you're going. And he's minding where he's going, and so the camera framing isn't the best. We're trimming off and clipping off part of the actress there. That's not really what we want. Okay, and of course, if you're too focused on where you're pointing the camera, you might find yourself taking out an Olympic class athlete, and that's no good for anyone. Okay, so really the question is, can AI help? And so drones already exist. There are drones out there that let you film, they'll maneuver themselves around the scene, they'll do self-localization, they'll do sort of path planning for themselves, and they'll also point the camera roughly where you are with some basic control that you can get. Now, we hoped and we thought that this would be it, but after speaking with more sort of expert filmmakers, we found out that this isn't necessarily a be-all and end-all. There are problems with drones. The first is, of course, safety. You can't have drones for most part indoors or in tight spaces. There's obviously a risk factor there, and they will ruin on-set audio. They are loud. Of course, drones will get better over time, but those problems still remain. And of course, yes, filmmakers want automation and they like it, but at the same time, they want more control and they want to have it in their own hands. There is some comfort to them of sort of being able to still be sort of have control over the camera and point it if that may be the case to film what they need to film. So really what we're trying to conclude is here, we don't want full automation. We want partway automation, or at least automation you can sort of hold in your hand and you can control and you can instruct it to do different things dynamically. We need an assistant. So we sort of tried to tackle this problem, and we asked filmmakers, well, what do you really want in a camera assistant? If we were to give you this tool now that will try to make your life easier using sort of whatever work we can bring forward, what does this kind of thing look like? And the one thing that you sort of the very first one, of course, is, focusing on safety. Like I want to be, the filmmaker wants to be able to focus on their own safety, even when they're maneuvering in tight spaces and still be able to film. So, and sort of on the left there, you can see a Steadicam operator filming what he needs to film, but at the same time has a spotter to help them maneuver. Let's say you don't have a spotter. How do you make it so that you can alone film a scene like this and have the camera do something that sort of makes your tasks easier? And whatever it is, whatever automation you bring to the table, it needs to be responsive, it needs to be dynamic, it needs to frame accurately. This is just a very quick example from what Lookout can do, a very, very, very simple use case. And just to sort of show what we mean by responsiveness and being dynamic. And ultimately, it needs to be controllable. It needs to be somehow controllable. Either you control it or you tell it to do certain things before filming, or during filming, you get to be able to tell it to do different things, or there's some communication that happens there. Okay, and now we introduce sort of our test bed for this. It's our system, it's called Lookout. And it's not very unlike most of the, sort of user interaction stuff that you've seen before. The system has a few basic components and we can go through them now. There is a camera on a gimbal that can, and this is motorized and we have control over where the camera points. There are earphones, and this is to enable Lookout to speak directly to the camera operator. It'll, in a very robotic voice, but nonetheless, it's able to tell the operator what's happening in the scene, or rather sort of what scripts or things they've instructed the camera to do, and what kind of behaviors that the camera is currently going through to do for them. And of course, there's just a backpack computer to figure out, sort of do all the number crunching in the background. And there's some kind of way of giving Lookout sort of sensing of the world. Here, we're mainly relying on visual sensing and some hearing, and we'll get to that in a bit. Okay, so what does sort of the filmmaking control that we can give to the users look like? Well, look, there's a GUI at the very beginning that gives users access to a bunch of camera behaviors. So these are things that Lookout can do automatically. The very, very basic stuff is not very interesting. Just, asking a camera to do a pan isn't hard. But then sort of the use case that's really core here is being able to follow and frame actors, multiple actors, or as little as, all the way down from one upwards in the scene with, and sort of there's nuance there. How do you want to frame them? How tight, how loose, that kind of thing. And of course, just having a single behavior isn't very exciting. The ability to say switch between one behavior and another is important, and in fact the user can have this happen either in advance by saying that, well, one behavior is linked to another via some cue. This could be something that's happening in the scene. Someone speaks a word, and so now the camera must follow something else. Or it's sort of a voice trigger, a command, a speech command, some kind of speech command that the user gives the system. And so this is an example of this. This is an example of Lookout with a very simple script. You can see here on the right. I'll walk you through it. So it's just following and switching between two actors. Any second now, you'll hear the camera operator shouting out a command. I hope the audio is going through there, but he just instructed the system to say, follow the primary actor. And now the second actor. And now both follow. Don't worry if the audio isn't coming through, you're not missing too much. He's just shouting voice commands to switch between all of these different behaviors that he instructed before. But as you can see, the Lookout will dynamically go between framing these different actors. Okay, how do we do this? Well, first, before we sort of dive into that, let's just very quickly gloss over, or not gloss over, but really dive deep into, actually, rather, an existing commercial solution. And in this case, it's the DJI Osmo. And it is exactly on the box. This is what it's supposed to do. It's supposed to follow an actor through a scene and just keep them in frame. You don't get much more control than that, but at least it satisfies the basic box. Like, it ticks one of the boxes. Unfortunately, though, for the kind of filmmaking that we're going for, it's not very robust. And by that, I mean, if the video were to come with me, there we go. By that, I mean, it loses track. That's as simple as that. And that's very unfortunate. If now you're a filmmaker and there are many things that can ruin your take, you don't want something else coming in as a potential point of failure. And in this case, we tried filming the same scene 9 times, and 8 times out of 9 doesn't really work. Okay. So let's go down deep to the nuts and bolts. Visual tracking is really hard, right? And it's an ongoing visual core vision problem, right? And there are many data sets out there that try to sort of help you in developing methods that perform well for visual tracking. And they vary in flavor. You can have data sets that are focused on sort of novel shape objects, so no certain semantic class, any semantic class is allowed, all the way to multiple targets. Many people, for example, and sort of one semantic class in this case, people, many people in the scene. But really, that's not the target we're going for here. What we need for camera framing and what we need for this task for sort of, if we're going to build this camera assistant, is to have a handful of actors. You're only interested in, say, again, one all the way to say at maximum 4 or 5 for complex scenes, a handful of actors for extended periods of time. You really have to be very robust to those targets. Being distracted even once ruins your take. It's not okay to know exactly where the target is for 90% of the time and then ruin it in the next 10%. You'd much rather be 85% and never be distracted at all. Okay, and you also have to be capable of recovery. And by this, all it means is if you lose an actor, if they hide behind something, you need to find them after they come back from the occlusion. And of course, be fully online and above real-time speeds, that is. And if you satisfy all these boxes, you get to do things like this, right? Where this is now sort of a lot of occlusions coming up where the actor is ducking and diving out of a complex scene. And your job, again, Lookout's job, the tracker anyway, is to know where this object is, and then for Lookout to use this information to keep them in frame. So we're using the tracking by detection paradigm, and I'm going to sort of go through some very basic details here at a very high level, but I encourage you to go to the paper if you'd like all the details on how this tracker actually works and deep down and sort of what we needed to do to make this happen for Lookout. But yeah, it's just tracking by detection. And what that means is you know who you need to, at one frame, you know who you need to follow, this one particular actor here marked with A. And in the next frame, there's a bunch of bounding boxes. You have an object detector, it tells you where the people are. And your job is to match A to D3 here accurately. So yeah, you need to distinguish which person is which, and you need some kind of information that can help you with distinguishing which person is which. And we use sort of the same, really the same paradigm that most tracking by detection algorithms in literature use, which is just some kind of appearance encoding. In our case, they come from a pair of Siamese networks where for every frame you get to have an encoding of the appearance of what your actor looks like. And sort of it's able to tell you now, or you're able to say, well, is F1 roughly the same as F2? Am I looking at the same actor or not? And the gist here is that you will have a dictionary of appearances for your actor. And in fact, that's what this is here. And there are a few challenges that you'd have to go through to sort of you'd have to solve in order to get this going for this use case. The first is that sort of you have to, like, this is really managing the size of this appearance history now. One of them is that you trim anything that's sort of not very useful information. And the other is that you cull your history somehow, so it doesn't become massive, so that it doesn't become intractable and now not real time. And of course, really, robustness. Again, you can't be distracted. So you have to make sure that as you're tracking, you don't manage to get encodings that might be overlapped with another person. And there are tricks, of course, to find out if that's happening and to prevent that from happening. And again, please go to the paper. We can link it definitely later, and you can find all the details there. Okay, alongside sort of the tracker, we also sort of provide a starter data set along with Lookout. This testbed now that sort of tries to push the boundary of what is sort of tracking, especially again a few actors in heavy occlusions, ducking in and out of occlusions as well, as you see there. And yes, this is in the paper, but it's just to say, yes, we do well on at least these videos, and we definitely do well in comparison to the other trackers when we actually use them inside Lookout, and I'll show you a video of that now. So yeah, this is revisiting the same scene now, shot with Lookout, but now with a few different trackers. On the left there, it's one of the state-of-the-art trackers in literature. On the right is our own. And yes, we do very, very well, at least for the scene. We managed to keep the target in frame, and we don't get distracted by anyone else. Okay. Now let's talk about sort of satisfying user commands. And by that, I mean sort of, well, how, you know where people are, how do you keep them in frame? And for that, sort of, this is the very generic high level sort of control loop that you'll see in most systems that do something kind of like this, heavily abstracted. The main problem here, though, is that your tracker locations are noisy. No matter how good your tracker is, at the end of the day, there's going to be some noise involved. And if you're not careful, it'll lead to sort of framing that looks like this, where there's definitely a lot of jitter and a lot of noise in sort of the framing that you end up getting out of something like Lookout. And yes, you can try filtering, but and that takes away from the camera responsiveness that you get. Our answer to this is to use dynamic filtering and make it even user controllable, so that now sort of, again, this is abstracted, but there are ways of defining locations where if an actor moves, you do nothing, and sort of you vary that. And again, the details of which are in the paper. And so, yeah, if you do this and if you do it right, and sort of this is an ablation, our system without the fancy filtering and our system with, and you can see there the difference in sort of quality of footage that you can end up getting. Okay, and of course, this is user controllable, so you can have it be sort of modular depending on what the user instructed. Here, it went from very loose following, sort of there's a large area where the actor can move and nothing happens, to very tight and responsive to immediate action. Okay, we're coming towards the end now, I promise, and then it's just videos that you can watch and ask questions along the way. So we've evaluated Lookout multiple ways. We evaluated the tracker separately in the control system, but we also sort of had real users use this. And not only that, but we also had experts look at the footage that we've gotten out of Lookout and sort of tell us their opinion. And most of them, sort of overwhelmingly, the response has been, we really want to use this. This seems like a very useful thing to have, especially if it is as robust as it is. Using it in scenes where, again, you're occupied, you're doing something else, maybe the crew size isn't very big, and so you have to be self reliant on keeping yourself safe, then they really want something like Lookout. This is example sort of footage showcasing most of the things that can happen in Lookout, and this includes camera zooming as well. You'll hear me. If you can't, that's okay. I'm instructing the camera to fire one of the behaviors I had programmed earlier, which just asks the camera to sort of have tighter framing on Hala here. Okay. So really, what's next? What are we trying to say here? Well, it's the first step. Lookout is really a first step, and it's trying to sort of push the boundary of what we can do for cinematography with AI in real life, sort of with a camera in your hand. And sort of realizing the system, and so far it's complete enough. It's a good enough test bed that at this point, you can start to swap out modules, right? And there's a lot of room for cool things to happen, especially things that involve more machine involvement, either through speech understanding, sort of trying to figure out the intent of what you're getting from the filmmaker, or through sort of this kind of style that you end up getting out of framing, and sort of learning that style and applying it on the fly. And yeah, from here on, it'll just be videos that you can watch. And please go ahead and ask any questions you like.
Thank you. If anyone has any questions for Mohammed, please do add them to the Q&A at the bottom of your screen. If there aren't any questions, then we will pause.
I see. Yeah, I think we have a minute left, and that's okay. Sharon is saying that she can't access the Q&A for questions.
That's because she's on the panel.
Okay, sorry.
Only people in the audience can add a question in the Q&A. We can read them.
Sure. Okay. I can answer that question. I'd like to ask whether this. So I'll read it out. I would like to ask whether this is envisaged for professional users or amateur content creators. So really, it's more helpful to think of not that specific axis of skill. So what we've heard is this is useful in many applications where either the budget is limited. That's maybe one of them, where you can't use any other filmmaking equipment. Say you can't put down a crane, or you can't put down railings through sort of a complex terrain. Or when you can't, again, sort of limited crew, and you can't help someone navigate a scene. So it's not so much amateur versus professional, but yes, of course, on the professional side, you'll tend to have the budget to make really anything possible and sort of upsert any of these constraints.
if you stop sharing your screen, you'll see there are a couple of questions in the Q&A.
Ah, okay. Sorry about that.
That's right. Oh, there's a few.
Is this, yeah, I see that. Is this software embedded in the camera system? So it's in Lookout. So Lookout, you can switch out the camera that you use for something else. Both the star and the guide camera is sort of what you used to see and what you used to film and what you used to control as well. So no, again, we'll release all the code and you can sort of play around with this and merge it with something else. The gimbal is sort of an open source gimbal firmware that we end up using. Did you mention this is digital optical focus, and what is the frame rate resolution? Sure. So the frame rate resolution. So with the current star camera that we have, we're very limited in what we can control when it comes to intrinsics. So the focus is currently sort of when it comes to the zoom. If I assume that's what you mean, this is a very small camera. Again, this is a prototype system, so it's sort of just digital zoom with some fancy sort of whatever Sony's fancy sensor cropping is. The frame rate resolution, it's something like 50 hertz for the guide camera. For the overall system for control, it's something closer to about 60 hertz with the tracker at around 30 hertz. Interesting work. How close are you commercializing this? Would you need to collaborate with camera making companies to integrate? So yeah, so there's definitely, this is really a student project. These are students in the PhDs and their supervisors. So this is our prototype. You can definitely start to think about how you can make this into a more fleshed out and complete system, of course. And the last question here. I mean, it could be possible. The same way it could be possible to use a car for whatever purpose, right? We're focused on AI, sort of cinematography here. So, I mean, anything is possible, right? But no, that's not our intent at all. Okay, I think that is all of the ones in the Q&A. Sure. I'll post the link to the camera research as soon as maybe right after I finish up here.